Welcome back. So today we're going to be talking about perpendicular lines. You should have a foldable that looks like this. Please make sure that you've cut along the bottom so that we can see all 5 of the tabs. Okay, so we're going to go ahead and start here. So our perpendicular lines, we're going to start this first one is the distance from a point to a line is the segment that is perpendicular to our line. So that's the shortest distance from any point to a line. So the shortest distance from point A to this line K is going to be the perpendicular segment here. Okay, so just quickly, I want to review our distance formula. So please write this on this page. So distance formula equals square root x2 minus x1 squared plus y2 minus y1 squared. Okay, because we're going to do a few examples, so we're going to need that formula. Let's go ahead and turn the page here. And I am going to zoom in so it's a little easier to see this one. All right, so we're going to be finding the distance from point E to line FH. So we have 3 different segments here. So the shortest distance from point E to line FH is going to be EG. So we want to find the length of EG. Okay, that's the one that we need to find the length of. So the points that we're going to use, E is at a -4, -3, and G is at 1, 2. So the first step in these is you have to figure out what is your segment. So ours is EG. Then we're going to use our distance formula, so square root. Remember, we're going to go x minus x. So I'm going to go 1 minus a -4 squared plus my y, so 2 minus a -3 squared. Then I'm going to work inside of my parentheses. So square root 1 minus a -4, so that's like 1 plus 4, which is 5, squared, plus my next parentheses, 2 minus a -3, that's also going to be 5, squared. Now we're going to work with our exponents. 5 squared is 25. 5 squared over here is another 25. So we're going to get square root of 50. Okay, and at this point, that is an acceptable answer, or you can approximate it using your calculator. But remember, if you approximate, to put the little approximate symbols there. Okay, all right, so let's keep moving. Let's go on to the other one. We're going to find the distance from point A, which is up here, to line BD down here. So remember, the shortest distance is the perpendicular segment. So that's going to be from A to C. So we're going to go from A, which is -3, 3, to point C, which is 1, -1. Okay, so again, we're going to do our distance formula for AC here. So square root, start with our x's, 1 minus -3 squared plus our y's, -1 minus 3 squared. Simplify inside of my parentheses first. 1 minus a -3 would be 4 squared, plus -1 minus 3 would be a -4 squared. You'll notice I put the -4 in parentheses because I want that whole thing to be squared, not just the 4. So then next is my exponents. 4 squared is 16. -4 squared is also 16. So we get the square root, scoot up here, square root of 32. And this is an acceptable answer. If you would like to approximate, you can also do that and then put your decimal answer there. Okay? All right, let's keep going. The next one is our linear pair. Sorry, let me scoot out just a little bit there. So the next one is our linear pair perpendicular theorem. So it says if 2 lines intersect to form a linear pair, remember a linear pair is that they are adjacent to each other and supplementary. Okay, so a linear pair of congruent angles, then the lines are perpendicular. Okay, so if they make a straight line 180 degrees and they're congruent to each other, congruent angles, then each one of them is going to be 90 degrees. Okay? All right, so we're going to come down here. We're going to determine which lines, if any, must be parallel and explain our reasoning. So we have some boxes here. We have some arc measurements. Okay, so if we know that angle 1 and angle 2 are congruent to each other, then we know that angle 1 has to equal 90 degrees and angle 2 has to equal 90 degrees. And that's this linear pair perpendicular theorem. Remember, this upside down capital T means perpendicular. Okay? So if those are both right angles, and let's see, 2 to this one down here, we're going to call that angle 3. 2 to angle 3, those are corresponding, and they're both right angles, so they're congruent. So if angle 2 is congruent to angle 3, let's see, so we're going to put here, this is corresponding, and this is the converse. Then we can say S is parallel to T, because we went from here to there. Let's try to go from here to here. Okay, so for this one, let's call this 4. Angle 4 and angle 2, those are both 90 degrees. So angle 4 is congruent to angle 2, and those are alternate exterior angles. So we can use the alternate exterior angle converse to say that then M is parallel to N. Okay, so we said this one's 90 and this one's 90. So then we know that M is going to be parallel to N. That was our alternate exterior angles converse. Okay. All right, let's keep moving. Next one is lines perpendicular to a transversal theorem. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. Okay, so it's saying if two lines are perpendicular to the same line, line P, then they're going to be parallel to each other. Okay, and that just makes sense because this would be corresponding angles. Okay, so determine which lines, if any, must be parallel and then explain our reasoning. Okay, so here, this angle, let's just number these 1, 2, and 3. So angle 2 is perpendicular to line M, and angle 1 is also perpendicular to line M. So angle 2 is perpendicular to line M, and angle 1 is perpendicular to line M. So then we can say that J is parallel to K, and that's using this theorem up here. So this is our lines perpendicular to a transversal theorem. Okay, let's look from here to here now. So we have angle 2 is perpendicular to line K, and angle 3 is perpendicular to line K. So then M has to be parallel to N. Same reason. Lines perpendicular to a transversal theorem. Okay? So if they're perpendicular to the same transversal, then they're parallel, then the lines are parallel to each other. All right, let's keep going. We've got one more. This last one is the perpendicular transversal theorem. So it says, in a plane, if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line. So it's saying if these lines are parallel and J is perpendicular to H, then J also has to be perpendicular to K. So let's see what that looks like down here. So we are going to, it says determine which lines, if any, must be parallel. Explain your reasoning. So if P is perpendicular to S, we don't know if Q is perpendicular to S, though. Can we say that P is parallel to Q? You're going to say no. The reason why. We don't know if Q is perpendicular to S. We would have to know that Q is perpendicular to S in order for that to work. Okay? All right. That's all I have for you today. This is going to get glued in your notebook, and you can start working on your practice problems. Have a great day.